All right. Hi, everyone. Um, I'm very happy to be here. It's been a fun week with a lot of interesting talks. And today I wanted to talk about a small side project that we've been working on during the pandemic that's been really fun and interesting to do. But to start, I wanted to give you a little bit of context on the kind of work that we do. So my name is Bertrand Schneider. I'm an assistant professor at the Harvard Graduate School of Education. And for the last 10 years, I've been doing work using sensor data in education, both in terms of trying to understand how learning happens, but also trying to put those tools in the hands of the students and have them do interesting projects where they can collect interesting data sets. And what I've seen is that this kind of data and those kinds of tools are easily available to researchers, but it's actually much more difficult to make them accessible to learners, even though that could be very important in terms of building data literacy skills. So that's sort of what this project is about, and that's what we're trying to address. So the motivation is really that access to good data, for us as researchers, it can allow us to capture more interesting constructs and events, obviously. But for learners, it can also turn anyone into an inspiring scientist and allow them to ask and answer important questions about the world around them. And we also hope that teachers could also benefit from having access to rich, fine-grained data, which is a goal of the learning analytics community in general, how we can raise awareness of the things that students are struggling with. So over the last 4 years, an attempt at solving this issue was this class that I taught called Multimodal Learning Analytics, where I have people with absolutely no technical background, people who don't know how to program, and I teach them how to collect physiological data, eye tracking data, motion sensing data. During the first half of the semester, we focus on creating visualizations to understand what the data tells you using Tableau. And then during the second half of the semester, we have them use a software called RapidMiner, which is a block-based environment where you can build machine learning pipelines without having to write any lines of code. And so by the end of the semester, people actually get a good handle of managing multimodal data sets. Those are examples of 3 different projects that students did. On the bottom left, let me go back. They asked a couple of teachers to wear an Empatica wristband, capturing the level of electrodermal activity, and they correlated that with levels of attention in a class of students, and they found a significant correlation between the two. On the top right, this was a project where people were interested in studying blind contour drawing, which is when you're trying to draw a model, but you can't look at the sheet of paper in front of you. And so they were relating eye movements with the performance at this task. And the project on the bottom right is probably my favorite. We had an ex-Montessori teacher take the class, and she was interested in capturing moments of concentrations in a Montessori classroom. And she used a Kinect sensor to capture body postures, and she used unsupervised machine learning, and she found those 2 states, one where the child was distracted, and the other one where the child was focused on the task in front of her. So just to say that after 13 weeks of learning how to use those tools, people were actually able to do interesting projects and to do interesting analysis on those data sets. So I think that there are a lot of benefits from this approach of having students collect their own data sets compared to traditional data science courses where they usually get a pre-created data set that's been collected for them and cleaned for them. The first one is that being able to collect your own data makes data analysis more engaging. You're more interested in your data set because you know where it comes from and you sort of have knowledge about the context in which it was collected. It builds more curiosity. You ask yourself more questions about the data. You have more inspirations in terms of coming up with interesting research questions, and that's really important in the data analysis process. Something else that's interesting is that it also allows you to better identify problems that you might have in your data or in your models. For example, biases that might be encoded in models that you're using. And also helps you identify limitations of the tools when you have missing data, why you have missing data, and so on. And usually we give students the ability to see the data in real time in the context, and makes it easier for them to understand what the data means. So for example, if you have some Kinect data that gives you a certain number for the location of a hand on the X, Y, Z plane, that data is probably going to be difficult for you to make sense of. But if you've seen the person move his hand and see the data in real time, what it looks like, it's probably going to be easier for you to digest, those huge table of numbers. So this kind of approach seems to work well with students. They're very engaged, they're very interested, they learn a lot. There are a couple of problems. The first one is that we have to provide all of those sensors to students. It's usually expensive. It's not something that they can afford. And most of the time you have to write your own code to collect the data. It doesn't come, pre-packaged with a nice user interface. So in the context of the class, we build a lot of tools to help students do the data collection. And then, there are also cloud services where you don't have to use physical sensors, but then you have to pay for the amount of data that you analyze. And the second big problem is that the pandemic happened. And so suddenly we're not able to lend sensors to students, which is how we were doing things in the past. So it really forced us to rethink how this course was being taught, which was a good thing and a bad thing. So we couldn't rely on physical sensors anymore, but luckily, there's been some fast technological improvements in terms of computer vision algorithms. So deep learning came out that works really well for computer vision. People released large labeled data sets that different groups were able to use to build good models. And then those models started becoming available on the browser. So you have JavaScript-based models that you can use to do those computer vision tasks. So what we ended up doing is to leverage all of those advancements to build a web-based tools that would replace all of those physical sensors and all of those moving pieces that we had. So here's a quick demo. This is what the website looks like right now. We're currently redesigning the interface. It's very bare bones right now, but you basically have different modalities and different tools that you can use to capture, for example, eye tracking data, motion data, affective states, and so on. So for example, if I were to click on emotion detection, I would get on this page, and then you can see that you can get the emotion data in real time. It gives you the probability of me expressing surprise or happiness or fear for every frame. And you can press a record button and then get the CSV file as an output. So it's extremely easy to use. And we have here a couple of examples of tools that we have. So you capture emotion data, you can capture pose data, you can do hand tracking, and we also have algorithms to do heart rate detection just from a webcam image. This is an algorithm that came out of MIT a few years ago that looks at micro changes of the color of your skin, and it's able to infer your heart rate based on that. It's a little noisy, but it still gives you a ballpark in terms of how fast your heart is beating. And then as an output, you can get those CSV files that you can easily download and then analyze. So on the left side, this is an example of some emotion data. So you get the likelihood of those emotions being expressed. And then on the right side, you have example of the skeletal data, pose data. So you get the X and Y location of different joints or different body parts. And then you get the frame that was analyzed, and then a person ID if a person was tracked over time. I'm going to do a quick live demo. So anyone can go on this website and use it and try it out. So you just need to type mmla.gsc.harvard.edu, and you're going to arrive on this page. Again, this is going to look very different in a few weeks, but this is what we have right now. And I'm just going to try one that I haven't shown you yet. So for example, you can do object detection. Let's see how well this works. Probably going to have issues. So it's seeing me, a person, seeing a cup. And then if I show a phone, it's detecting a cell phone. And what you can do is just press the record button here. And it's going to record all of those things that are being shown and detected on the screen. Then you can stop and you can download a CSV file. So it's really easy to use. Our goal was really to remove all of those obstacles that students have to overcome to get access to those data, to those types of data streams. So a few words about the technical aspect of things. So how does it work? So something that's important to know is that we're using mostly JavaScript machine learning models. And people don't need to install any library, anything in particular. You just need to have a webcam and a browser, and you can run those models and collect those data sets. So the models run entirely within the web browser, which also means that the data does not leave the user's device. So it's not like the data is being sent to a server, processed, and then sent back. Everything is processed locally, which is a huge plus in terms of data privacy. And the other advantage is that the computation is offloaded to the user's device. So it's using the CPU or the GPU of the user as opposed to using a data processing center where you would need a bunch of machines to do all of that work. So it's much more efficient and much more distributed. It's also more scalable because it's totally web-based. It runs in JavaScript. Like I said, you don't need any expensive data processing center, but you also don't need any API. You don't need to program anything. You can just go on that website, and basically anyone can collect data from those different tools. And our goal is to make it extremely user-friendly so that it's usable by very young students. It's also usable by teachers potentially. But we also want these tools to be useful to researchers as well. So there are a lot of people who have interesting data sets who would probably benefit from those types of data, but they don't have the time or the knowledge to work with those models programmatically. And something that we do on this website is to also allow people to post-process videos. So you don't need to do everything in real time. If you have a bunch of videos, you can also just run through those models and get the data back. Something else that we've been trying to do is to be as open and transparent as possible. So we also provide the source code of all of those tools on the website. So there's this column here that links mostly to GitHub repos. So what you can do is if you have a platform where you're interested in collecting those types of data sets, you can download the code and then implement that on your own platform as well. So coming back to the class that I talked about earlier in this presentation, this tool that we built last year, and we taught this class again last fall, this allowed us to reimagine what this class on multimodal learning analytics would be. So we taught the same course, but online, and we used this tool instead of providing students with physical sensors, and it worked pretty well. Students were able to collect the data that they needed, and we're also able to do things that we would not be able to do in person. So we were able to scale things up. We were limited to having 20 students in the normal class because of the number of sensors that we had. In the fall, we had more than 50, 60 students. We were able to teach people from all over the world. So we had people from Thailand, China, Korea, Australia, Norway, Ireland, India, and more countries. We were able to provide access to more tools, more modalities. So we were able to give people access to object detection algorithms, hand tracking, fiducial tracking, things that we didn't have in the original version of the class. And we're also able to design new kinds of learning activities. So as part of this class, we designed this learning portal, which is basically just a website where students can watch videos and they can learn about those different topics related to multimodal learning analytics. But we also told them that we're going to collect data as they were watching the videos, and we got their consent to collect that data. And we collected emotion data, pose tracking data, and eye tracking data during the entire semester when they're watching those videos. And we turned that into a mini quantified self project. So at the end of the semester, and actually during the whole semester, students could access their own data. And at the end, they downloaded the entire data set and they used this data to correlate those multimodal data sets with quiz scores. So they actually used their own data to try to predict how well they were able to score on the quizzes that followed all of those videos. And for some of the students, this was their favorite assignment of the semester because they were able to work on data that related to their own learning. So they knew the whole context of how and when this data was collected, and made the exercise much more interesting to be able to look at their own scores and relate multimodal data to that. Just as a side note, we also did some interesting things on this learning portal. Students could also indicate their affective state as they were watching the videos, and we gave them the summary of the entire class and also themselves. And they could see how the entire class felt throughout watching the video. So for students, that was extremely useful because if they were frustrated and they saw that other students were frustrated or confused, this helped them, make the step of asking a question about the content. And for the teaching team, this was extremely useful to know that, minute 8 or 9 was probably not very well designed and there was some confusion there. And this is also an interesting ground truth to make sense of the multimodal data later on. But moving on, I also want to mention a couple of limitations and issues. So not everything went smoothly. We also had quite a few problems and issues that we had to solve on the fly. Quite a few of those models perform worse than physical sensors. So for example, web-based eye tracking is not great. It can give you a rough sense of where people are looking on the screen, but it's nowhere near having a physical eye tracker. Same for heart rate, but it can give you a ballpark. And for most of the exercises that we had students do, this was good enough. And we also found out that some models didn't work well with non-Caucasian ethnic groups, which was an interesting opportunity to talk about the training data that was used and biases encoded in those models. And this really generated interesting conversations about some of the discriminations that can take place when you don't look at how the model was trained and built. Remote debugging was much harder than in person. It's really much nicer to be able to sit next to a student and solve technical problems with them. But having the models on a browser actually made things easier. So not having to deal with installing drivers and libraries was really nice. For example, with the Kinect sensor, you need to have a Windows machine, you need to install a bunch of things, and it's quite a few steps where students can get lost. And finally, as you probably all know, building community was much more difficult online. When I teach this class in person, you can tell that people are really working well together, they're helping each other, there's a good sense of community. And online, it's much more difficult to have people feel like they're having the same experience and that they can support each other. And we also found that the projects were a bit less diversified. There were more screen-based studies, less classroom and ecological environments, both because of the nature of the tools that we provided, but also because they didn't have access to those spaces. So I'm going to wrap up. So as future work, we're interested in scaling up, in trying to have online data science platforms use those tools so that students can also learn about data collection and data cleaning, which is something that's often overlooked in those types of courses. We're also interested in tailoring the platform to maybe help teachers. So there are other models that we're currently working on and trying to implement. So for example, we're working with some of those MIT people who've designed this model that does gaze estimation just based on video images. And so that's information that could be useful for teachers to know, what are students paying attention to in classrooms, but also in more open-ended learning environments. And finally, we're also interested in tailoring this platform to support researchers. Like I said earlier, there are a lot of people who have really interesting video data, and just having the ability to run their data through the tools and get, fine-grained quantitative data sets would allow them to answer maybe new research questions or different research questions. So I'm going to wrap up. So for us, the pandemic was an interesting opportunity to rethink how we learn, teach, and do research. It was a great way to think outside the box and try to develop new tools and do things differently. We're also pretty lucky that timing was right. This is when a lot of those JavaScript-based models were released. So that really helped us. And in conclusions, we're really excited by the potential of this kind of tool to support constructionist learning, where students can conduct their own projects and learn in communities and sort of share their artifacts and projects. All right, sorry I'm a little bit over time, but thank you so much for your attention, and I'm very happy to take questions.
Great, wonderful. Thanks so much. That was a great talk. And we'll do some clapping there. And so I'd like to throw first to Bertie Heinemann to ask a question. If you're comfortable asking on the, and sorry if I mispronounced your name.
Oh, that's no problem. It's hard for everyone outside from Germany. So I also read the paper, and in future work you wrote about the intention to use studies to build models for web-based multimodal learning analytics. I think that's a great idea. And how did you currently decide which models and data specifications to use to collect the data for your students or for the user?
Yeah, that's a great question. So you mean which models did we decide to include on the website? We basically looked at all of the possible models that we could use, and we just listed all of them because there are not that many models that are open source and that you can use freely. A lot of them you basically have to pay something to get access to those models. But one thing that we're doing in the redesign of the website is to inform the users of the pros and cons of different models so that they know what are the limitations of those models, when are they appropriate, when can they trust the data or not. And I think that's really important so that people can make informed decisions. If you know of models that would be interesting to provide on this website and we don't have them on the list, please let me know.
Great, wonderful. Javier, are you getting ready to ask a question? I can see you moving.
Yeah. Hi, Bertrand. I love what you did. A crisis turned into an opportunity. I have similar problems in my courses, how you use multimodal data. I want to ask, have you been thinking also in the second part of the thing, when they get the data, to also do the fusion and analysis on the same web browser, or do you think it's better for them to use the other tools like RapidMiner? So it's better to have one integrated environment, or it's better for them to, take pieces here and there?
Yeah, that's a really good question. And I've been going back and forth between which tools to use, what's the best approach, how to make the learning experience the easiest. And I think it would be great to have more tools on the website, but we have to build all of them. And that's a huge undertaking, especially when other people have done the work of trying to build interfaces that are easy to use and intuitive. And Tableau and RapidMiner are great choices because they're free for students. You can get an educational license and you can use them for free. And they're very powerful, and you can do very, very interesting things with them. But something that I think would be interesting to include on the website is to provide more fine-grained measures or more interesting measures that you can directly provide in the CSV file. So for example, one thing that I would love to do is to have specific metrics for people who study collaborative learning. So let's say you have a setup with two students working together. You can derive a lot of interesting metrics in terms of their body positions, in terms of, are they oriented towards each other? If you have a sense of the direction of the gaze, you can have a sense of how much time they spend looking roughly at the same place at the same time. And this idea of joint visual attention is a good proxy for collaboration quality. So that's the thing I would do first, and then maybe try to include more tools if I have an army of CS students who are willing to do this.
Thank you, Bertrand.
I have a quick question, but it's probably not a quick question, but a question around when you're using real data with students, that can turn into a time sink for them. Do you have any tips on how to manage that? Like that can become the class?
Yeah, that's a really good question. So in the class, we're very intentional to start with pretty simple data sets that have very few columns. So we do things with, let's say, heart rate data or eye tracking data, where you just have the X and Y location of a person's gaze on screen. And we provide them with tools to double check their data. So for example, we help them display the eye tracking data on, let's say, a slide that the user is looking at. And then they can sort of check that the data looks okay, and they can do those sanity checks themselves. And then we move on to more and more complex, not just data sets, but assignments. So the assignments become more and more open-ended as we go through the semester. And then for the final project, they can basically do anything. They can, collect data from any setting that they're interested in and try to make sense of the data. And so at the end of the semester, there's obviously more work needed from the teaching team to support those students, to help them define research questions and clean the data and sort of help them through those steps. But it's also the project that's, I think, the more rewarding and interesting to them, because they get to answer their own questions that, they're excited to answer. So the scaffolding is really important. That's sort of the answer.
Right, yeah, that makes sense. Thanks so much. Does anyone else have any further questions?
Thank you for your presentation. Wonderful work you are doing. And my question is, what were the behavioral changes in students when they realized about their project on themselves?
Yeah, that's a great question. So we were very transparent from day one. We told them exactly what kind of data was going to be collected. We had them sign consent forms, so they knew exactly, that this was happening. And we made it very clear that they had the option of not taking part. And most people just forgot about it. They just didn't mention it at all. But when we heard from students, they're mostly concerned by the quality of the data that was being collected. So they asked us questions like, what should I do in front of my webcam to make sure that I have good data? Or what should I avoid? Or is that a problem? Is someone, passes behind me, and is that going to add noise to my data and make it more difficult for me to analyze it? So it was positive in the sense that they started asking questions about the quality of the data and how environmental factor would affect that. And I think that was positive, in the sense of building data literacy skills.